Okay, guys, we're on our last lesson and we're going to talk about real numbers. And really, we're just going to distinguish between what is a rational number and what is irrational. So here we have the real number set. Everything that's in the white is considered a real number. And then on the left, all of these numbers are rational and the numbers on the right are irrational. So the goal is to be able to identify all of these as being rational. And these are the types of numbers that are irrational. So in your notes, let's jot down what you see here. A rational number, and I'm going to highlight the word ratio within that word. A rational number is a number that can be expressed as a ratio or a fraction. So if you can write a number as a fraction, it is rational. Sometimes we're giving an illustration as a decimal or a square root. And so you need to be able to identify if that is rational or not. So I'm going to go through each of these and tell you why it is rational. So all of these are examples of rational numbers. So obviously this is written as a fraction, so that is rational. If I read this properly, I say 6 and 25 hundredths, which is a fraction, therefore it's rational. The square root of 4 is perfect, and so when I take the square root of 4, I get 2, and then any integer can be put over a 1 to create a fraction, so this is why this number is a rational number. 8 can be put over 1, showing a fraction, so it is rational. 7 and 1/2 is written as a fraction. And when you have a repeating decimal, so for one thing, just know that repeating and rational both start with R and they go together. But let me show you the mathematical reason why a repeating decimal is rational. When I have two digits repeating, I take those two digits and I put it over two nines, 45 over 99. So this is rational because I can write it as a fraction. And we're going to learn about the 9 rule, quote unquote 9 rule, later in this lesson. Now let's take a look at irrational numbers. They are numbers that cannot be expressed as a fraction because it goes on forever without repeating. It does not terminate, which means it does not come to an end, and it does not repeat, like 1, 2, 1, 2, 1, 2. So let's look at this example first. You can see that this decimal does not terminate, it doesn't come to an end. These three dots, these ellipses, tell me that it keeps going on and on. It's not repeating, and that's why this is irrational. You need to know these two words, non-repeating and non-terminating decimals are irrational. Both pi and the square root of 3 would end up looking like a decimal such as this. They would go on forever without repeating and without terminating. Here's a quick list of the summary if you want to pause the video and jot this down. Now here is the quick way to write a repeating decimal as a fraction. So I have 2 and 3 repeating, so I have 3 and it's one digit, so I'm going to put it over 1, 9. So this is what makes this rational. Here I have 4 and 9, and I'm going to put it over, we'll go ahead and put the 0 there, 99. I have two digits repeating, which would simplify to 1 over 11. And we can go ahead and simplify this as well. Then I have 0.267 and I have three digits repeating. So I'm going to put it over 999. So this is rational. So this is what makes a repeating decimal rational because we can write it as a fraction. Now I'm going to go through each of these and let's convert them to, if we can, let's write it as a ratio. And if not, then we know it's irrational. But the square root of 12 is not perfect, so it is an irrational number. -3 can convert to -3 over 1. Pi, we already said, is irrational. 2.173 terminates. Therefore, it's rational. We have negative 3.276, and it doesn't repeat and it doesn't terminate, so it is irrational. Don't forget your ellipses. The square root of 49, oh, I forgot, let's turn this into a fraction. And it's tenths, hundredths, thousandths. Here we have the square root of 49, which is 7, and we can put it over 1. This is a perfect square, so we get negative 14, and we can put it over 1. We have pi in that expression, so it's irrational. The square root of 400 is perfect, so it's irrational. We have 5 and then 12 over 99. So this is rational. We have negative 2/3. That's already a fraction. We have a terminating decimal, 4 and 12 hundredths. 4 and 5 over 9, 4.5 repeating. Look, guys, on this one, the square root of 1 is 1, and the square root of 9 is 3. So this was like consists of two perfect squares, so it's rational. 3/7 is already a fraction. This one, it does not end, and it does not repeat. The square root of negative square root of 3, 2 radical 3. Now look at this one. Pi over pi is really 1, and we can put 1 over 1. So this expression is really a rational expression. Whoops. Don't know what happened there, went off the board. And then lastly, 21, and we can write 21 over 1. And that's it, guys. I hope this helps.